Hi everyone, welcome to the Car Chat podcast. I'm Sam Moores, and with me today I have Steve Drummond. Hello.
How do you do?
Very good, very good. Can you tell the listeners a little bit about who you are and what you do?
Okay, my name's Steve. I run Electrogenic. Electrogenic is, what do we do here? We develop EV drivetrains. We're famous for putting those into classic cars, but we also develop drivetrains for a number of other uses.
And we are at Base today. How did this all begin? Have you been involved in automotive all your life, or found it later on?
Yeah, I have not actually. So my background is as an engineer. So I started off in nuclear design, and have been through most aspects of the power industry actually, and a lot of renewables and that sort of thing. So been working in one aspect or another of green energy for 20, 30 years now. Where you got into cars really was thinking, well, for the first time it was becoming possible to build an EV that you'd actually want to own. And that led us to buy some parts, realize that we didn't really like the parts, to make the parts instead. And then fast forward 6 years to today, and we have this big technology suite of all sorts of products that go into all sorts of vehicles.
Interesting. And I know before this, you're saying you've been involved in a lot of energy-based things, and particularly green. Is that the alongside? Why did you pick cars? Are you been a car fan forever, or technology?
More of a motorbike guy, to be fair. Why cars is because I've always been interested in sustainability. Just from the point of view it's obvious common sense. Why waste stuff when you don't need to?
Yeah.
Resources are limited, best to use them to best effect. Yeah. If you look at the future moving forwards, impact of climate change, looking for fossil-free ways of making the world work in a nice, comfortable way, in the way we'd like it to work, right? Transport's a big part of the equation. So I've done a lot on the generation side. I'm also involved on the energy efficiency side in domestic settings through other enterprises I'm involved in. But the big unsolved problem was transport. And so that's why it was interesting. I've always been interested in new technology, in ways of doing things in a new way, how to sort of advance knowledge, if you like. So EVs seemed to be the next thing, and so started looking into it, realized that it really was possible to actually start to make something pretty cool, and then got deeper and deeper and deeper involved.
and when you joined the space, were there other people in it?
Yeah, the pioneering stuff was done in the States actually. So when we first started thinking about this, I went over to the States and to see what they were doing. That's 60 years ago. A lot has changed in 6 years. Yeah.
What, like, this? Can you give me some basic examples of sort of where we've gone from, but I know where we've come to?
So we develop our own sort of EV drivetrain systems. What that means in practice is that, so if you're Ford's, for example, you want to design a car, what you do is you go buy a motor from a motor manufacturer, an inverter from an inverter manufacturer, et cetera, et cetera. You source all your components, and then you tie those all together with the mechanical engineering design and also the control systems. So your VCU software, all of that. So we're doing the same thing. If you rewind 6 years ago, there weren't really any components, because the whole sort of automotive electric vehicle thing was only just getting going, and the big manufacturers were behind the curve. And so then all of their suppliers weren't producing the product either. So the big thing that's changed in the last 6 years is the availability of components. So, we make our own drivetrains, we do all of our design integration, it's our own software, but we don't manufacture motors, we don't manufacture battery modules, we're not chemists. And so those things, the availability and the variety and the capability of those things has changed beyond all recognition in the last 6 years.
Is that a challenge that I imagine this is a challenge like moving forward, because you look how much everything's changed in 10 years, and whether it's designing a package for a car now or designing a package for a car in 3 years' time, how do you keep pace with the technology changes and how everything's evolving so fast?
So we're in the industry, so we're very much plugged into what's going on, and it's what we like to do. So we're sort of really interested in the new developments and what's coming through. And also actually a lot of it is because we are challenged with new applications. We have people coming to so we develop drivetrains for converting existing vehicles, so a range of them, classics and others. But also then we're designing drivetrains for car manufacturers, the small ones, who don't have that in-house capability, and also for the military. And so those customers bring us challenges, and then we're looking for technology to be able to deliver exactly what they want in terms of power, torque, how the drivetrain's organised, price point, of course, if it's a production vehicle, all of that sort of thing. So there's always continual challenges and continual ways and also to simplify what we're doing. So we might, for example, at the moment we're going through a change in the battery modules we're using because we're trying to simplify our design. Mm-hmm. So for certain vehicles where the finished battery box is bigger, we can use bigger modules inside. That reduces the number of bus bars we need to manufacture, reduces overall costs. Our long-term aim is to obviously reduce costs in real time, in real terms, so that the price of the product comes down. Yeah. And so it's continual innovation like that, and making sure we take advantage of what is out there.
Yeah. And was there a plan and the strategy from the very beginning to end up sort of going down the various avenues you've got, or you sort of worked it out as demand and such has happened along the way? Yeah.
So originally, actually, we started off B2B originally, but shortly after we hired it, we did a whole load of R&D for 2-3 years, built some cars, and picked up some industrial customers, and then hired some people, and then 2 weeks later we had the first lockdown. So timing's everything. So and our corporate customers ran away. So what we did was we paid a little bit more attention to our website. Set out our stall B2C, found individual customers who wanted their cars converted, developed tech to convert their cars. And then the cumulative effect of that has been that, first of all, we've been challenged to do a lot of different things in big varieties, from a Citroen DS, which has its hydro pneumatic suspension. So we had to develop an electric pumping system for that, to a little old Morris Minor, which isn't that complicated, but actually its suspension isn't great. So you have to really minimize weight. And the customer wanted to be able to drive to Wales on a charge. Okay. And you multiply through all the different vehicles. We developed, with the help of Innovate UK during the pandemic, a system for farmers to retrofit a Land Rover. But the idea is at a very low cost, so building down to a price, so very simplified technology. So they get a 3-year payback on diesel savings if they fit the kit. So it's been a big variety of challenge, if you like. And then we filmed all those things, put them on YouTube, put them on the socials, and so our brand has grown. And then more industrial customers getting to know who we are through that, and so the industrial side of it's now coming back quite strongly.
Has the sort of customer changed throughout the years? As I guess initially, maybe more sort of evangelical people that are like, I just want to do an EV conversion. I love tech, I love EV, etc. And then presumably the farmers, I imagine they're not necessarily that.
Farmers are absolutely pragmatic, hard nosed. Am I going to save money? Yeah. How long is it going to take to pay it back? Can I get it cheaper? It's a very straightforward conversation. Probably our early customers were pretty much all people, perhaps a little bit older, owned their car for a while, wanted to give the old sort of family car a new lease of life, or had always dreamed of it being. A lot of them always dreamed of it being electric. And now as a possibility, for the first time ever, it's possible. So these are our sort of early customers. And that category of perhaps an older customer who's had a car for a while and now wants to give it a new lease of life. That's a continuing sort of group, if you like. The new group that's grown up, particularly over the last couple of years, is perhaps younger, professional, like the idea of it being green, probably lives in London, is looking at ULEZ charges, thinking, I'd really like to have quite a cooler. I want to go EV. I don't want to pay ULEZ charges, but I don't really want to buy I want a car that I want.
Yeah.
And so, and may also actually always fancy the classic car, but don't fancy the inconvenience of keeping it on the road. And so then they'll go out and buy a car in order to convert it. So they talk to us about what car should I buy, and we say, well, anything you like really, but if you want a 911, I go down this route or whatever it is, and then they buy the car and then we convert it.
I think that neatly comes into something that we've had a bit of conversation earlier about, one of the things, and one of the sort of criticisms I've come across from, I'm not going to say petrolheads because I think that's the wrong, car people in that space, has been around taking a classic car that doesn't get driven much and then putting in a battery pack, and the sort of CO2 payback of that if the car doesn't get driven very much. Like, why would you do it? Is it green? Is there any point doing it? We talked a little bit about this, but can you cover some of your thoughts around that?
I mean, I think generally speaking, the sort of people that say that it's a slightly synthetic response because it's spurious, right? So the argument, it's making the argument that you shouldn't drive your car much, which is fine, but then what's it for? You may as well scrap it, crush it. What's the point in having a car that you never use, right? So if you're going to use it, then make it EV because it's reliable. It won't not only start and get you to the pub, it'll get you back again. And if you're going to use your car, then the EV is a greener option. Even more so. So what we tend to find is our customers not only just drive their new electric converted classic vehicle. Now and again, it turns it into a daily driver. And so what you're actually doing in that example of you and the sort of ULEZ, I want an EV, but I want one my way. What you're actually doing is avoiding the manufacture of a whole new EV. And then you really are saving in-train emissions, et cetera, et cetera, et cetera. So it depends what you want to measure. But so our customers are corporates who, particularly with Land Rovers for land management, all that sort of thing, they're just doing it on the economics and they're saving, that they have CSR objectives, but also they're saving money on diesel and maintenance. Some particular vehicles that we convert, have very high maintenance, have for example, gearboxes which cost a lot which get worn out quickly, cost a lot to maintain. We replace that. So you a lot of avoided costs. Our individual customers tend to end up driving the car a lot, and a lot of our customers use their classic EV as a daily driver.
Yeah, that's and I hadn't really thought about that side of it, but as you brought that up and we talked a little bit about earlier, like I have a little EV, but I also have a stupid E63 estate, and if I didn't have the EV, what I found is as soon as I got the EV, I drove that in town all the time, and we do 5,000 miles in that a year. If I put those 5,000 miles on my E63, slightly different experience, whatever, but drove it around town, I'd get, 14 mpg. So you are actually offsetting. If you're taking one and then doing the other, you're offsetting an insane amount versus driving a very inefficient car around town, which I hadn't really thought of as a thing. But now every time I drive that, I go, not only are there no tailpipe emissions or that sort of thing, but also I'm not driving what I would be driving, which would be significantly worse. So that is an interesting side on it. From the very beginning, do you accept if someone says, I want you to convert, I don't know, something that you've not done before, if you just approach it and gone, we'll work it out, let's do it. Or if you tried to sort of go, let's find a range of models that we do.
We've basically taken the approach that we'll do any car more or less within reason. Partly that was the pandemic, and so we were happy to have the work.
Yeah.
Now we are perhaps slightly more directed. So the way the business, the classic conversion business now is evolving for us, is that we're limited in the number of cars that we can do ourselves by our physical premises.
Yeah.
And also we have a global audience, and we have inquiries from all over the place. And so what we're doing now is we're packaging, we have deep experience in particular models. So we're packaging our tech into very sophisticated drop-in kits, literally 2 or 3 units that you bolt in, and then all you do is bolt on the prop shaft or however the drivetrain is, and then wire up the dashboard, and away you go. We're distributing those through partner installers all over the world. At the moment, we're focusing on developing our network in the UK and the USA, but we have conversations going in a lot of places. And that enables us to do exports. And so then when we come back to the bespoke business, which we'll carry on doing because it's great because it challenges us to do new things all the time. We sort of rather naturally prefer to do either sort of big iconic vehicles, which will get a lot of attention, obviously, or vehicles where we think there's going to be a lot of demand. So, for example, there's a DeLorean down there that we're converting. I think there might, DeLorean engines are a bit naff, really. I think there might be a lot of demand for a DeLorean conversion, partly because it's got a bad engine, partly because it sort of screams to be electric, doesn't it?
Yeah, Back to the Future.
So there's an example of a car we're delighted to do as a bespoke conversion, because from that, we'll get to really understand the car. We'll have all of the scans, all of the designs all worked out, and then we can produce a kit that can be installed by one of our partners.
And these kits, when you put them in the car, are most of the cars you work on, are they all the same? As in, when you put the kit in, you look in and you go, yeah, that measures that measures that across them, or are there some brands in cars that are just a nightmare?
Yes and no. We've never come across a Land Rover Defender which has the chassis rails exactly the same part, distance apart as another one. So for example, for the Land Rover Defender kit, the way we do that is we have an adjustable mounting tray that bolts into the chassis on existing bolt points, but it accommodates the slight changes in production. Yeah. And then our tech bolts directly to that, so that we have to design around some of the historical variations, really.
And what is the process like from sort of start to finish? If someone comes and says, I want to, let's do the bespoke process versus the sort of drop in.
So first of all, you sit down with the customer and say, well, how do you want to use your car? How do you want to drive it? What do you want from this? You want to be a sprinter. You want to do long range. How do you drive it? What's it for? Purpose of that is to size the motor. So we're getting the right power and torque that's to enable the car to do what you want it to do. We would counsel customers not to go overboard. Our idea is the way we like to approach things is to make the car a better version of itself. So Citroën DS is a great example of a car where it was always right from birth given the wrong engine because of French emissions categories and blah blah. So we give it the power and torque it perhaps should have had, and then in terms of range, your range is more batteries or fewer batteries, and very strongly advise the customer to go easy on the range, because what you don't want to do is put too many batteries in, weigh the car down and change the way it handles. So typically you'll find that the car is its original curb weight plus or minus 60 to 100 kilos.
Okay, not much different, yeah.
No, so the E-Type that you drove in today, for example, that's net 90 kilos lighter than the original. It's a bit heavier at the back, so it's better traction, a bit lighter at the front, so it steers nicely. other cars maybe 60 kilos more, so it's the weight of a small child. So it's not material in the context of the car. A car will still handle the same way.
Yeah.
And that's really important. So then you've got your basic design, which is you get your motor that sets the voltage. Then you have various battery combinations you can put in to get to that voltage, that and number of battery modules, which is sort of discrete. It's not variable. No, it's not too variable. And that gives you your kilowatt hours, max kilowatt hours. That will give you the range according to the weight and the aerodynamics of the vehicle. And then it's about what do you want the vehicle to do. So the control systems allowed us to develop different profiles for eco and sport and hill descent and traffic and all those things. So there's that big conversation about how you want to use and drive the car. That then develops into a specification. Then car comes in. We scan it, so we have all the drive lines, the original drive lines for the drive shafts, etc. So that we make sure everything's going back in exactly the same place. And then we take out all the bits we don't need. So the engine, sometimes the gearbox. So we do conversions with a manual box. Some customers want to have that active driving experience, so that's something we can give them. Obviously, don't need the fuel tank, don't need the exhaust. So we take those parts out. Then scan it again. And then we have the whole of the available space digitally inside the CAD. Then we do from the initial discussions, we produce a sort of high architect engineering sort of concept of where the battery's going, a charger, all of these things to make the weight right, make the cooling system as compact as possible, so you don't have airlocks bleeding a cooling system between the front and the back of the car, and how we're going to how we're going to deal with brakes, all this stuff. So that goes into the CAD, come up with a design, then that's then checked by our electrical guys, make sure that there's enough physical space in the battery box to make sure that because according to the architecture, the way you wire the battery modules inside the box changes. So making sure that inside the box you've got the right wiring, so you can hook up the bus bars to the batteries in the right way, get all the battery management systems in. So all of that, then a big sign-off process for all the design process. Then we'll cut metal, test fit, empty boxes, and transmissions, make sure everything fits. Sometimes it doesn't, because as much as anything, scan accuracy over sort of a large area like the void where the engine was is we need accuracy to within 0.2, 0.3 mil, and in reality sometimes it can be a couple of mils out. So you do adjustments, and then any adjustments you make to the bare boxes goes back into the CAD. So then we have all of that saved for next time. Everything's right, you then send things off for powder coating, and then you build up all of the physical battery modules, bus bars, all of that physical electronics in, bolt everything in, and then there's an electronics commissioning procedure, so that you progressively test all the systems individually, and then you test them as a block, and then you RPM limit the motor, and then you test the motor with the wheels off the floor, and then you test it with the wheels on the floor. So it does its first drive, and then you do a commissioning process to go through, prove everything. And then if it's a first vehicle, you also then do a lot of calibrating. So we do a whole bunch of driving, and we adjust adjust the way that the motor and the controller responds to driving style, to the weight of the vehicle, to the aerodynamics of the vehicle, and give control modes that reflect what the customer is trying to achieve, but actually then delivering that electronically. And then the other part that I forgot, right, going back to the beginning, also we'll have a visual design context. So it's very important for us that the cars look good, because the customer's changing their vehicle, and they want to be able to have it look to reflect the care and attention they put into it technically, and they're specifying everything. It wants to visually reflect that as well.
So do most of it like the bespoke ones, are they all full restorations as well, or
Usually not.
serious restorations?
So we don't do the restoration work here. It's a service we can provide and do provide for some customers. So we project manage. So we know good painters, good bodywork people, et cetera, et cetera. So we will, if a customer wants us to, so we'll essentially project management. So we'll take the car in and then we'll organise. And we've done quite a number of those full refurbs, bare metal restorations, new paint colours, complete new upholstery, all of that. So we can do that, yeah.
Because I know it's a problem with any classic car, but if you're uprating stuff, but just generally, a car comes in the door, unless you blast everything back to zero, how do you know what's underneath? How do you know that you've got solid structure? How do you approach that?
So car comes in, we do. We've got a car acceptance procedure. Check the seals and the brakes and all of those things. We very much prefer to have a car drive in, so that we can drive it and see what we think about the suspension, the brakes, and so on before we take it apart. Doesn't always happen. Very often, if there's a restoration involved, the car will come to us with no engine. Which is then we just need to deal with. The other thing I should have said is when the car comes in, we put it on. The important is we put it on the corner weights. So the way a car balances is important to the way it drives. Not to say that we wouldn't change that, but we change it consciously rather than unconsciously. We want to know what it is. We check it all over for all points check, and then we'll say to the customer, you really need to change the brakes because the calipers are all gone to hell, and all of that stuff. So it's a process.
And with moving weight around the vehicle in different ways, putting different elements that weigh different amounts to original, is there any re-engineering of the substructures and stuff?
No, because going back to sort of deciding how we do the overall specification of the car, we're always making sure that we're not putting lots of extra weight in. Apart from the military Land Rovers, but that's a whole different thing.
Yeah.
So for example, with the E-Type, we've taken about 120 kilos out of the front, and net we've added 30 kilos at the back. Now,
It's not that much.
It's not that much. It makes a difference actually, because the criticism of the classic thing with an E-Type is they wrap themselves around trees because the back end's really light. That's where all the power is.
Yeah.
People lose it on corners and spin off and bang. So we've redressed the balance a bit. Not so much that it still doesn't drive like an E-Type, but you definitely get the power down better, and it's lighter on its feet, which is nice.
Yeah. Has the batteries, like the way they come now versus, I know you can get them in they're built out of packs versus, you get two types, can't you? You can have the little cylinder jobbies, then build up, or you can have sort of packs. Yeah. As that's evolved, has that made it easier or different to split stuff up? And can you just split battery packs up and move them around the car and put them in different places and things?
Yeah, we can. So what we tend to do is we buy modules. So this is typically like the size of a small shoebox. Inside that are either the little pen cells or pouches. Depends which manufacturer, depends what terminal voltage, what kilowatt hour storage inside the unit. But it's a CALB. It's called CALB. It's a CALB sort of format, if you like. It's a standard car industry format, and you can get different terminal voltages, different kilowatt hour storages, but same physical size. Same physical bolt patterns.
Okay.
And that's the most cost-effective way for us to buy batteries. If we went, of course, we could buy little pen cells and manufacture our own, but that's expensive and not really warranted for what we're doing.
Yeah.
So we have those modules, and then what we have is a number of sophisticated systems for mounting those in different configurations, because they're designed to be bolted down to a flat surface underneath the car floor in a new EV, and we don't have that luxury, so we've got to put them in a box or two boxes in different parts of the vehicle. So We have a system to be able to mount those in different orientations, but also make the assembly of the battery box straightforward. So that's part of our internal sort of tech development.
Yeah, I know with modern EVs, it's all about putting the battery generally lowered in the middle of the car in a big, strong structure, although I think they're now starting to become part of the structure.
Yeah.
But in the view of if you have an accident or something, it's harder for the battery packs to get damaged. What sort of safety things have you put in the cars to sort of help with basically not turning the whole car live and all those sorts of things?
Yeah, sure. So basically our conversion is exactly the same tech as a brand new EV, right? So and it's multiple nested approaches. There's all the software systems which control the car, figure out if something untoward is going on and shut it down. That's the overall management system. But if you build from the bottom up, from inside the batteries outwards, then there are a number of subsystems that are doing their own thing anyway, whatever the VCU is doing, and we'll take over and we'll stop the car. So inside the battery box, you have a sophisticated battery management system. What that's doing is it's making sure that the voltage of all of the cells within the whole battery pack, that's all balanced, so that all the cells are going up and down in concert. Make sure that they're all within their proper voltages and so on, that the battery stays nice and comfortable and in its preferred operating environment. And that's monitored by a series of microprocessors, and if anything looks out of whack, it'll build up a number of tally points, and then if it thinks, okay, there's too much of this, it'll signal the driver, pull over and stop. And then there'll be a fault code that we can interpret and so on.
How does it do that? Does it sort of reduce power drastically or something?
It depends, but usually a light on the dashboard, and then if the owner ignores it, it'll start to reduce power. And it's a safety system never, under normal circumstances, never get used. I mean, the most obvious time when that would come into play is if you're simply driving and ignoring all the signals. You'll get a warning light that starts blinking when you've got 20% of the battery left, and when you've got 10% left, it'll go on red, and then you should be pulling over, and then it'll start limiting power. So it essentially automatically puts you into eco mode, and then it'll be more severe than that. So it manages you so that you cannot take the battery down too low, because the battery doesn't like that.
Yeah.
So you were talking about for crashes, that sort of thing. So the other part of the battery management system is that there's temperature sensors in there. So if there's anything untoward going on with battery, it sees elevated temperature, will shut down all use of the battery, so there's no power going through it. The next level is that battery modules are inside a big box, steel box. The steel box, the terminals are tamper-proof, so the plus and minus coming out of the box, they're tamper-proof, UN certified boxes. Terminals, so you can't get, even if you undo it, you can't get your fingers in there. So that's another level. But inside the box, you have two contactors, so that anyway, unless the VCU has gone through all of its checks to make sure everything's fine, it's not supplying electricity to the terminals. So even if you could get your fingers into the tamper-proof things, anyway, there's no electricity there. There's a thing called HVIL, which is it essentially checks to make sure that all of the connectors are connected fully. Because if you have a connector that's not properly connected for whatever reason, it can get hot, a bit of resistance. So it checks for that. If things aren't connected properly, the car won't go. You have a crash switch, so if there's a crash, again, car won't go. So you have a whole bunch of nested systems.
Yeah, it would be quite nice to have those actually in a petrol car. Like, fuel is leaking, by the way, just FYI.
Oh yeah, of course, yeah. And then of course, that's another thing. So if electricity is leaking, theoretically impossible, but you never know. So there's another system that monitors if there's any. So the HV is a closed system. So it's not like, people sometimes think, because if you've got your 12-volt system in your car, the car body is often used as a return path. Obviously not happening in the HV side of things. But if there's any leakage between the HV side of things and the side of the battery box or any part of the car, for example, again, shuts the system off.
Okay.
So it's a lot of systems. Yeah.
It sounds like it's being thought about and rapidly evolving. Is there lots of legislation around what you have to do now and that sort of thing? Or
the answer is yes and no. There is no specific legislation for converting cars. There's less legislation for building new ones. There's two parts, two UN. There were the European regulations adopted by the UN. One's called R100.01. So and that's about electrical safety. So that's about checking resistance between live parts and the rest of the car, all that sort of thing. So it's a whole series of special checks. So all of our kits comply with that, for example. R100.02 is about crash testing EVs. So we're not crash testing our customers' cars, so we're not doing that. But yeah. And then in terms of rules for converting cars, they're different in every country. So we just comply with local rules. So UK DVLA has rules for converting. You might put a Mazda engine in a Trans Spitfire, same rules. So we have the same thing.
So there's no
specific thing, no.
Is that tricky when you're starting to send stuff abroad or to be installed in different countries and stuff, that actually each country has their own different regulations?
It's complex. So in the States, for example, the rules are you can more or less do anything you like, but it has to be done in the States. So
obviously,
so hence we make the kits. The kits get shipped over to our partner installer in the States. So then the conversion work's done there. So fine. In France, the rules are more or less that it can't go faster than the original, which is a shame for a 2CV, for example. It's a big shame for a 2CV. If you're a conversion shop in France, then the first one you do of a particular vehicle needs to be homologated, which is just one of those things. But the other thing is that the work has to be done in France. So, vive la différence. So, those are the rules in France. So, for France, if somebody wants our tech, it needs to be installed in France. And the rules are different. Every country, the rules are different. Just depends.
Yeah, so I guess, and it makes more sense the more of a single car you've done, because they've done one, they're now allowed to do another. Or in your sense, is it kit-based or is it car-based for, let's say you've sent it to France?
That is a good question. And there are the other set of regulations that we need to deal with is UN 38.3, which is about the transport of batteries. Okay. So if we manufacture a kit here, then we're sending it to the States, for example, then we have to comply with the UN legislation for transporting it because it's a battery. And that's obviously a big point of debate with the authorities that we're having at the moment, which is, we've got 3 different Defender kits. So the way you comply with UN 38.3 is you spend about £100,000. You pay somebody £80,000 to £100,000 to drop 3 of your battery boxes, which cost you £150,000, onto a concrete floor and see what happens, right?
Right, okay.
It's not sophisticated. There's £250,000 just gone, right? So when you get the certificate, does that apply to, we do 3 different Defender models. That's
they're all slightly different.
All slightly different, but and so it's a good question, and obviously we have a point of view, which is that they're all the same. So just do it once, please.
Yeah. I heard about one. I don't know whether this is a new vehicles thing or a different thing, about a test where you have to put a battery pack on some fuel basically and set it on fire for it's quite a long time. And the battery pack has to survive.
They're talking about bringing in a UN R100.03, and there's a lot of discussion about what will be in that. Last time we were down at Millbrook, we were putting a car through R100 and having it independently verified. Yeah. They were doing some of the sort of research work, if you like, for the maybe new regulation. What they were doing was they were drilling a hole in the side of a battery box. then retiring to a safe distance, firing a 6-inch nail into it and seeing what happened. So one of the things is, for example, that it needs to give you X number of minutes before it goes boom to get out the car. So,
you fall off a cliff, roll down a hill, how long before it explodes?
Exactly. Yeah. So that's the regulations that they're talking about.
What are they trying to do in terms of transporting batteries? Because there's been quite a few, say, high-profile ships disappearing with battery fires, transporting people's expensive cars. Are they now changing processes around transporting cars? Because obviously you don't want a big boatload of cars.
I mean, that's what UN 38.3 is about. The question is, why do batteries catch fire?
Yeah.
Either they've been significantly mechanically damaged, just penetrated basically. You've got something sharp that's gone into the vitals of the battery, or it's been abused electrically. And if it's abused electrically, then you can start off a little chemical process that will fizz away and then start a chain reaction much later. So the trick is buying batteries from the manufacturer brand new, or some customers prefer second-hand batteries for CSR reasons, but they do a full battery test. So we basically test every single battery that comes in here. We test anyway, whether it's new or not, and just make sure that the whole thing's fine before you put it in the car. And that's the biggest safety thing that you can do. Other thing to say about that aspect of batteries is it's changing, because battery chemistry is changing. So we experiment with different sorts of battery tech. So one thing that we've been playing with is battery tech called lithium titanate, LTO. It's not used in the cars at the moment because it's about, for a given kilowatt hour storage, is about 1.4 times the volume and weight.
Okay.
So,
why would you do that? Yeah.
Yeah, you just get a lower range, right? So, but you can do what you like to an LTO battery. It's never going to catch fire.
Okay.
Unless if you set a fire underneath it, eventually, yes. But but it's not. You can penetrate it. You can machine gun it. You can electrically abuse it. It's not going to catch fire. Now, to Toshiba, for example, so we work with them. They're saying that in 2025, they're going to have commercially available. They're the kings of LTO. They're going to have a commercially available an LTO battery, which is the same energy density and the same price point as today's lithium-ion batteries. So that's pretty interesting, not just from that sort of perspective, but also because a lot of the reason you put in the big thermal management and all the complicated systems which add dead weight and complexity and money is for fast charging.
Right.
And so an LTO battery, you don't need any of that stuff. You just charge it quickly.
Oh, okay.
So then you've got a prospect of a car that you can recharge in 15
yeah.
minutes, and hey, then that's actually a game changer.
Yeah, because one of the, I know initially when I first come across EVs, I was like, okay, surely you just you plug it in and whatever you're getting, 100 kilowatts. It's just going to fill up at 100 kilowatts until the amount of seconds that you've calculated that should take.
Like that, yeah.
And actually it's significantly more complicated than that. And there's loads of algorithms around charging curves and the way you charge a battery.
Yeah.
I didn't know until recently that when you plug into an electric charger and it doesn't work, it's not necessarily the charger.
Yeah.
It could be the car.
It could be anything, yeah.
It could be all sorts of stuff.
Yeah.
How does that work in terms of in your cars, for example, if someone plugs in and it doesn't work, or what are the common issues that stop things charging?
Why are things not charged? A whole combination of issues. Actually, the common one for us is that some people, it's a classic airport one where you leave your car on the airport for 4 weeks and come back, it won't charge, won't start. The reason is because the 12-volt batteries wound
Right,
down,
yeah.
right? So in order for the car to go, you need to connect those two little contactors in the battery box to allow the electricity out of the battery box so it can go to the motor so your car can drive away. To do that, you need 12 volts. And if you left the whole system on and you've got a drain because you want to keep your radio memory pre-charged and you've got a physical clock because it's a classic car, blah, 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 blah. In 4 weeks, you can run your 12-volt battery down. So that's one reason. So we put a little override switch. So if you're really leaving the car, you can switch the 12 volts off. You'll lose your memory on your radio, but you'll be able to drive off when you arrive back in the morning.
Okay.
What the Type 2 charger does is it initiates a conversation between the charge point and the car. And so it says, this is the capacity of the charge point, this is the capacity of the cable, this is the capacity of the car, and then the battery management system in the car then determines how much electricity and at what rate it will take from the charge point.
Right.
Charge point doesn't chuck it in. Charge point has it there available, and the car uses it. So if there's another charging issue, the next most common one is that actually not the car; it's that you've got a weird charger. So there's a standard. It's called EU Type 2, and that determines the communication protocols between
those systems. Yeah.
And it's possibly the worst written standard in the history of I don't know. So the thing is, it's hugely open to interpretation. So, for example, Nissan Leafs couldn't plug into any of the Ecotricity charge points early on. And the reason is because Ecotricity had read the standard, interpreted it in one way, Nissan had read the standard, interpreted it another, and the two wouldn't talk to each other. And so with our charging systems, we've been doing it long enough. We've seen most things. We still very occasionally, if somebody has a complex programmable charge point on their house, which is also managing the solar and on-charge batteries, and they've organized it in a certain way, then there can be interface issues. But, you go with a laptop, you do a diagnosis, sort it out, and once it's sorted, it's sorted.
Okay, and is that evolving, the standards?
No. Which is what it is. It's stuck now. It can't evolve because if it did evolve, then all the charge points have already been installed and all the cars have already been, they wouldn't work. So that's the trouble. It's just that,
Because in America, has Ford just said they're going to a Tesla, which is not a Type 2 in America? I think so.
Yeah, I think so, yeah.
Which
it's a cooler thing, right? So Tesla the Tesla charge point looks like a Type 2, but the Type 2 just does AC, so fast charging.
Yeah.
Doesn't do DC rapid charging. So in Europe, the Type 2 and all the European Teslas get fitted with this now. You get the CCS Type 2, so it's got it's got the round thing plus those two big, the two bulbous charge points on the bottom, which is basically a BMW design. Now, Tesla is able to do the DC charging through a thing that looks just like a Type 2, so it's much smaller and more elegant. For us, that's lovely because the number one issue for us with CCS charging, which is sort of standard on
fitting it, I guess,
is finding somewhere to fit the socket. Yeah, the car you drove today actually has got a US Type 1 charger in it because it's going off overseas. But some cars the petrol flap's big enough, and other cars it isn't, and we have to find somewhere else for it.
Yeah, in general terms, it sounds like absolute carnage. Like we need one standard. If the US standard is Tesla,
VHS
fine.
It's VHS and Betamax, isn't it?
Yeah. But turning up with one's quite different. One you just put it in, you can't put it in your watch a movie. Yeah. One you can't charge.
Yeah. But you don't usually move cars between Europe and the States. So is it practically an issue?
That's fine.
Yeah. I mean, the thing you have seen over the last few years is that they were to standards for rapid charging, which was CHAdeMO
Yeah.
and CCS. And CHAdeMO is a Japanese standard, which was the first cars here in Nissan Leaf, so they were fitted with it and so on. And CHAdeMO is being phased out, and CCS is becoming the one standard in Europe, for example.
Yeah. And that's all I see, all I use now. We don't seem. It's a problem that the States seem to have is people cutting cables.
Oh, I don't know.
Yeah. I heard
That sounds
about
a bit nuts.
the other day, which sounds one. They've clearly someone worked out that they're not live. We now know they're not live because they're not until the cars talk to each other or something.
Yeah.
But if you don't know that, you're going to go up to a 800-volt cable or whatever it is, and take some pliers to it. You're a braver person than me. What do you think, seeing moving forwards? I know you did working on some military stuff. Do you think we'll see military vehicles being EV, a complete switch pretty soon? Are there lots of advantages or disadvantages to that?
Yeah, the military see a lot of advantages over a whole range of different, for lots of different reasons, basically. One is that the overall cycle efficiency of taking diesel, which is UN fuel, and it's transportable, and making a vehicle move from a forward operation base into a theatre. It's much more efficient to do that by generating electricity efficiently and putting electricity into the vehicle than it is by putting diesel directly in. You got an overall saving about a third of the fuel at your forward operating base, and it takes 7 litres of fuel to get 1 litre of fuel into a forward operating base, and 3,000 deaths and injuries for the US military, for example, just running convoys in Afghanistan, fuel convoys. So that's one big thing.
That's crazy.
Yeah. They're looking forward to new energy, to new weapon systems, directed energy systems and so on. That requires large mobile batteries. An EV is a mobile battery system. Soldiers have increasingly wearable tech they need to be able to plug in. They see the vehicle as a mobile battery. So part of our spec for the military vehicles is actually to use the vehicle to charge a mini grid. So that ambulance out there, you can boil a kettle and make a cup of tea, running off the main battery. So, for example, and then there's the sort of stealth. Obviously, it's quieter. It's got no heat signature. Big one is driver fatigue. So it's much more complicated to be making sure you're in the right gear and you're revving quite the right way to get yourself out of trouble off-road in a diesel vehicle, whereas an electric one pedal, it just goes. Control modes, so we can put control modes in to make hill descents easy. Again, you don't need to think so much, you just switch it and carry on dealing with the other things that are going on around you. So there's a lot of advantages for them, and so they are really looking in. But they're at the beginning of that whole sort of thought process, and so we're helping them. So we're making trial battlefield vehicles so they can develop their ideas and put that into specifications for the next round of R&D and that sort of thing.
Yeah, because they don't. Military in general don't. I know that US Army has just changed, or very recently, to a new vehicle. And then they keep that for, well, who knows, 40 years or something.
Yeah.
So would this be your sort of, basically what you guys do? You build a powertrain kit that they would put into existing vehicles, or are they looking at just
the
new
idea
vehicle?
Actually is, so if you look at the main general purpose vehicle, it's all a Land Rover base, right? So that's all for just general transport and so on, but also for sort of thing the SS driving around Iraq in, sort of armored versions. It's called a WMIC. So now Land Rover stopped making them in 2015. So the British military is now looking at a whole new replacement vehicle. Yeah. And so EV obviously be part of that. The question is how to specify it, how to go about that, and so on. So that's part of what we're working with them on. And with,
you were saying about we have a big battery pack, and then like a conventional EV on the road has a 12-volt battery, and all the systems run off 12-volt.
Yeah.
Are people moving? I know Tesla's talked about it, maybe doing a 48-volt system. Is there a world when it's all one, in sense of you've got a big battery pack and everything just kind of works off that. Is that possible, or we're going to need some inverters and stuff?
You got your big battery pack that runs at whatever voltage you're running your motor at. And you go all back to the whole specification thing.
Yeah.
We run part of the vehicle systems at high voltage. So, for example, air conditioning pumps. So compressors for air conditioning, heaters, those things, much more efficient at high voltage.
Right.
So we'll run those at high voltage. Military, for example, lots of comms is 24 volt, some 48. So that's then a DC-DC conversion down from the main battery voltage to your operating voltage. And then, of course, all your existing car stuff is made for 12 volts. So you need that. So that's another DC-DC. But your standard charger comes with the 12 volts DC-DC integrated anyway. So it's a straightforward thing to do.
Yeah. Do you think we will see a big change from standard component manufacturers stopping making 12 volt stuff?
No. No, because it's so embedded.
It's done.
I mean, I know once upon a time it was 6 volts, but there was reasons for moving away from that. There's not a lot of reason to move away from 12 volts for most stuff. It's just the high current stuff. And like I say, for example, compressors and so on, you can make them run at a main battery voltage anyway.
Yeah. It would be nice if you came back to your car, and I think it must have happened to me in an EV where the 12 volt battery's dead, and you carry a little jump pack or whatever. It's like the new thing that you have to carry around if you've got an EV. It's like you have to have a little jump pack in case it's cold or whatever, or something's gone wrong, and you've got to jump it. Some way of just like pressing a button on the car and it gives it a little boot. Just fill it back up again. Thank you very much. I don't need to carry around a jump pack. Get on with our lives.
We give people for vehicles that are going to be used intermittently, customers who travel, for example. If they want us to, we can put them in isolation switch on the 12 volts. That's the easiest thing. You just switch it off.
Yeah, that's it.
And then that's it. And then it just sits there until they come back. Very simple.
Yeah, very much. Right. Well, I normally wrap these up with 5 questions.
Okay.
Do you have a most memorable driving trip or journey?
Yeah, but it was on a motorbike.
That's fine.
So once upon a time, me and my friend who's Chilean, we there was a while when the Paris-Dakar was in Chile and Argentina. So we got our bikes and we followed them across the Atacama, and we slept under a huge Chilean flag, which was supported between the two bikes in the desert. I had one of the funniest moments of my life when I woke up to see him dancing half in and half out of his sleeping bag because there was a scorpion in there with him. It was great.
That sounds pretty fun. Are there any other places? Presumably doing a trip like that on a bike is quite different to doing it in a car.
Yeah, because you're out there in the elements. I have to say, I love driving that E-Type because it's soft top. I'm originally Australian. Nobody has soft top cars in Australia because it's too hot.
It's too hot, yeah.
Yeah, you stop at the lights and you die. But in England, it's lovely.
It's so nice driving around in that car earlier. And actually, I didn't really think about it being electric. For me, that sort of drive, it's old enough that I'm like, we've got no seatbelts. I'm not hooning this car around. I'm not interested in dying anytime soon. Actually just cruising around. And then cruising around in an EV, and you still have noises of the powertrain and whatever. It was just nice, perfect day for it.
Yeah, The thing that the time when I really noticed that. So driving along local country roads, sunny, top down, beautiful, overtaking a car at 50, and I suddenly realised I could hear the birds singing in the trees, and that's because it was an EV, and that was the air.
Yeah. It's a different element, isn't it? It's another experience that's different, and people have multiple cars, people have different experiences, so it's good to try a bit of everything. If you could only drive one car, sports car, for the rest of your life, what would it be? I
really like 356, a little Porsche 356. Though, having said that, our 964 conversion is really nice. It's really nice. And it drives... So the 911 conversions we do drive the most like a motorbike of all the cars we do.
And what do you mean by that?
You come around a corner, there's a car in front of you, there's space in front of them, you put your foot down and you just go, poof.
Yeah.
You don't have to think about it, it's just there. And it's instant and it's fast. And the whole car's supporting you and you're off. Yeah.
Nice. I need to drive one of these 911 conversions at some
do,
point.
yeah.
What do you think is the most undervalued car at the moment? What should be worth more?
I don't know. Tell you what. So one of our apprentices just bought a big old Volvo, you know, the huge old Volvo estates.
Yeah.
For like $1,500. It's a really cool car, actually.
That is a cool car.
Yeah.
But not a lot of money.
For not a lot of money, you can do an awful lot with that. Yeah.
Yeah. Fair. Most interesting car to you at the moment? What are you Googling? What are you looking up? What are you researching? Top of your mind?
We're just talking to somebody about doing a classic Range Rover, which is straightforward in the sense that all the drivetrain is the same as a Defender. It's just basically the same as our Defender kit, except packaged slightly differently. I'd just love to do one. I think they're really cool, and I think there's demand for them. So that's the one I'm looking at.
Do you have to integrate with more interesting suspension systems, I guess, at that point?
We're not really adding hardly any net weight, and we're distributing it a little better, so I'm not anticipating any issues.
Yeah.
The real estate under the car is slightly different, and a Range Rover, you want to have good range, so we're going to look at that. But yeah,
that would be a great town vehicle.
Yeah, it would. Yeah,
it'd be very nice. 5-car garage, unlimited value.
I'd like a Citroen XM.
Okay.
Yeah, they're cool.
Would you have a daily? Would that be your daily?
Could be, especially if it was electric.
So we get down to one. Okay, fine. No worries. Well, thanks very much for coming on the podcast.
Yeah, my pleasure.